So now let's welcome Tiago for his oral presentation about the paper of Semantics-Aware, multimodal domain translation from LiDAR point cloud to panoramic color images. So this paper has also won our Best Student Paper Award as we introduced in the morning. So we hope that everyone enjoyed the talk. And Tiago, the stage is yours.
Okay, so you already present. So it's a work done on my PhD by me and my supervisor, Aaron Aksai. I'll start by give a bit of a motivation behind our work and then move on to the inputs of our network, the pipeline, some results and what we intend to do in the future. So the motivation behind our work, as I guess you all know, it's for autonomous vehicles. We start by having a sense that semantic perception is a very strong and core block when you talk about autonomous vehicles, and thus for that we need networks that can do real-time semantic segmentation. And also, when you think about autonomous vehicles, you think about vehicles that have different modalities of sensors. So in the case of our paper, we assume that the car only has two, the RGB and the LiDAR. That's when you have several, you try to do some kind of sensor fusion to try to have stronger representations that you can use later on for your networks. But that creates a dependency that all the modalities need to be online. So if one fails, you might have some kind of drop in the accuracy or a totally system failure. So to try to fix that, we are trying to integrate a sensor mapping or domain adaptation into the pipeline of the autonomous vehicle. This will allow us to completely avoid total system failure and also try to recover some of the missing data points of the modality that is offline. Another motivator behind our work is the semantic segmentation itself. We have a hypothesis that using, in this scenario, the semantic segmentation as a middle step will make our network stronger and learn faster and better mapping between one modality to the other. So these are the main motivators behind our work. So as I said, we are assuming a scenario that we have only two sensors and one is failing. In this case, the RGB is failing. So we'll have as inputs the LiDAR point clouds that will use a spherical projection. So we have a 3D 360 of the LiDAR. And we will also have what we are trying to recover in this case will be the RGB, both the real RGB and the semantic segmentations. In this case, as you can see on the semantic segmentation maps, they flicker a bit because the semantic kitty is a data set mostly for segmentation of LiDAR. So you need to use a third network to have this ground truth that we'll use in our pipeline. On the pipeline, you can see that the first step that we are going to do is having the semantic segmentation of the RGB that will be done by the SDNet. We'll have also the same semantic segmentation on the LiDAR that will be the 360 as I showed you before. And our network will be a Wasserstein GAN, a conditional Wasserstein GAN. So the condition in this case, as I said, it will be the semantic segmentation that we see as a strong conditioner for the network. And our discriminator will be a patch style discriminator, so like pixel-pix, for example. And this will give us the fake segments that we are looking after, the modality that failed and we are trying to recover. Then after that, you can feed that to a third network, if you like, to recover the real RGB. So this will be the agnostic, domain agnostic parts, because you can feed it to a network that was trained on Kitty, for example. So it will recover RGB that looks like, resembles the Kitty data set, or for example, cityscape. So you can do, it will be both domain agnostic and you can so look at it as a bit of data augmentation if you want to use it for another type of works. So this is the main overview of our pipeline. The network that we trained and we are looking after to have is the TitanNet. So in terms of the results, first of all, we can see on the first column will be the ground truth, the middle column will be the Titanet, and the last column will be the pix-to-pix. We didn't perform a lot of baseline comparisons yet. We did it with the pix-to-pix in this setting. And we also can see in terms of IRU in the different classes that Semantic-Aware provides that we are outperforming pix-to-pix, and we can recover a lot of the missing modality. It's still not perfect. We would like to have a better one in terms of persons, to have the core classes when you're talking about the autonomous vehicle, that will be roads, cars, sidewalk, and person, because it's what you want to have the strongest fast. Still, it shows that you can recover a great part of the missing modality. We also tried to remove the condition on the GAN to show that it's really necessary to recover faster and train better. In this case, we have two different baselines that you compare to. The SCUNet we didn't try before because of the inputs it takes, so it's not possible to use it on the conditional part, but we can see that without the semantic segmentation maps, there is a huge drop in terms of quality of the RGB that you get. So this is also a strong indicator that using the semantic segmentation maps of the still online modality is a good middle step for the recovery of the offline modality. I also have some videos, so if we start by the bottom ones, the first one on the bottom will be the Kitty real RGB. The middle one will be a V2V train on Kitty, so it uses our generated semantic segmentation maps and tries to then generate the RGB as it was a Kitty. The last one will be the same setting, but for the cityscapes. Also, the first video, because we are working on paired cropped LiDAR with RGB, because it's the same field of view when you are training, but also because we are on a fully convolutional neural network, it means that we can use any type of size of inputs. We decided to also create a 360 of the RGB. So it's a complete hallucination of the network on the entirety of the LiDAR. And it kind of doesn't work bad. I mean, it still needs to be improved, but it shows that it also a fully autonomous vehicle, because you can see everything and do a pairing between LiDAR and RGB, even if it's hallucinated. But yeah, this is the most exciting part in my point of view of of our results. And yeah, the future the future work that we are trying to do now, it's jump on the wagon of transformers, because a lot of papers on vision and transformers. So we are trying to check if that will help us recover more of the missing modality in terms of the smaller classes, for example. Another thing will be for the trying to make it more stable, because if you remember from the video, it flickers a bit because there is no temporal stability yet. So we are trying to work on that to make it make better. So instance segmentation could be a way to go. We are testing with both instance and how to introduce temporal information. And yeah, thank you for your time, and that's it.
Thanks, Tiago, for the presentation, and also congratulations again to your paper that have won our Best Student Paper Award. So I do have one question. But by the way, the demo you showed is really looking great. I kind of saw it when you submit the paper very early. So here you are generating the panoramic image, right? The corner image.
Yes.
But like in fact, the LiDAR point cloud that you use as inputs is only contain the geometry information, right? The points, basically. So there is no corner information at all. So in that sense,
no.
Yeah, so in that sense, the corner information you generate in the output is more like it's just a guess by network, right? So it's totally a guess. So in that sense, it's really depends on the data you're trained on. For example, if you train on Kitty, you probably just generate like Kitty style corner.
Exactly.
But if you train on other city or other countries, it's totally different. It can be very different. So I'm just saying maybe the corner doesn't really matter, because we can't really determine it at all. I mean, there's no way you can determine the corner from point cloud. So maybe we can just generate the segmentation, right? Because the segmentation is like
what the
yeah.
that's
go
right.
ahead.
That's what TitanNet does. We only care about the segmentation map. What we thought after having the segmentation map is we can now use a third network, in this case V2Vids, to see how good it would recover the RGB image. So from our semantic segmentation maps, we use another network that can be used, for example, for data augmentation. If you don't want to use it on the vehicle, we can use it to generate more data on the distribution of that data set, for either KID or cityscapes in these two examples. Could be seen as that as well. Yeah.
So the color image generation is not the final purpose. It's more like using as a proxy task. Yeah. Okay, that totally makes sense. Okay.
Yeah.
Great. So yeah, thanks again for your talk.